Hey, so wanted to take a little bit of time to go over the quiz with you in a little bit more in depth than just posting a key, and maybe give you some test topics. And I wanted you to see me with like no mask. I feel so different. Maybe I'm not even me. But one thing about me that is different is that, wow, it's so cold. So I've got like 3 layers on, and yeah, somehow we're going to get through this, and it's even not the worst of it. So in any event, let's go on and let's open up the quiz and look at it in a little more depth and maybe do some test topics. All right, so here's page 1 of the quiz, and I don't think I need to really read to you the problem, since if you took the quiz, you already did do that. First off, we need to define two proportions. What some of you did was to define one, like P is the true difference in proportions between patients receiving plasma, not receiving blah, 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 blah. All right, that's not going to fly. When we're doing two proportion procedures, we need to define two proportions. The reason being is at the end, if we need to illustrate why there may be a completely negative group of quantities in your confidence interval or completely positive, you can use P1 and P2 previously defined to show the order that you did the subtraction, or that you ran the test so that it would come out the way it did. Yeah, so it's really important. It may seem a little bit more important to do it with z-tests as opposed to z-intervals, but we're just going to be doing it for both. So make sure you've got that done. That's 5 points for getting that. So then we had to do assumptions. Here, most people that missed anything at all, missed the independent. All right, just didn't say SRS and independent. That was 3 points off. The whole section was 5, but the most you could lose would be 5. You could leave the whole thing out and just lose 5 points. But if you wrote it, it's kind of like the first mistake was 3 points off. Although for this part right here, when you verify normality, you have to say sampling distribution. And too many people did not refer to any distribution or to just some vague generic distribution. We are in a sampling distribution for all possible proportion or difference in proportions for samples of these sizes. So you just can't say all exceed 10, so the distribution is normal. It's sort of like, what distribution is normal? So that was 2 points off. Most people got that the populations were at least 10 times the sample size, although I would see that in this problem and not the second problem, or vice versa. Make sure that you're listing 4 products here so that you can confirm that they're all over 10. Don't just do like this one and then leave out the other 2. All right, the next thing that was gradable was naming this. You've got to name it what it is. You can't say that it's results for a 2 proportion z-interval test, because which one is it, an interval or a test? Now granted, I've taught you that you can use an interval in place of a test of significance, but those of you who did it pretty much bombed it or just didn't quite get it right. So please stick with whatever it is. If it gives you an alpha, it's a test. If it gives you a confidence level, it's an interval. All right. So for right now, keep consistent. Don't try to get creative and do your tests as a confidence interval until you know for a fact that you can get it right. All right. So excuse me, got a little tickle in the throat. So yeah, name this properly. And then this is the correct way to show it. I had a lot of people who showed it to me as the way the calculator shows it. And that's fine for now, but from now on I may be deducting for that because not everybody uses a TI-Nspire or 84 to generate their answer. So if you're using a computer and that's all you've ever seen, and somebody reports it as though it was in a in a calculator, you may not know what that is. Like, it's sort of like, okay, I'm not sure what my confidence interval is because I've never seen it reported this way. All right, so you need two things to clean this up. One is 5 points, and then the other is 5 points. So we are 95% confident that the true difference in the proportions of scarred patients receiving plasma treatments and not receiving plasma treatment falls in the interval, blah, blah, blah. Since 0, now this is the second gradable thing, because you've got to look for 0 in these two proportion Z intervals, because otherwise there's really not much point in doing it. And most people who miss points in here in this section did not check for 0. All right, you got to do it. And it's not included, and since both values are positive, and since I did note the order of the subtraction, there is evidence that plasma treatment reduces scarring in burn patients at a 95% level. All right, the least I was expecting is that you would say that you didn't find 0, which is evidence of a difference. If you said that much, you were good, all right? If you could go beyond that, then you're really revealing things to your reader, and that's a good thing. But I wasn't expecting that for as early on in the process as we are. All right, so there were other people for whom I just looked at what you did, and it was so different from standard grading that I might have taken a point or two off here or there. If you're not sure, feel free to ask. But in any event, that kind of wraps up this. So I want to go ahead and move on to the next. All right, so here we are on page 2, and this was about the spruce moth infestations, and there was an area that they treated and with some kind of spray, and then another area that they didn't. And the question is, do these data indicate that the proportion of spruce trees killed by moths is lower in the sprayed areas? Okay, so here again, you had to set up two proportions as far as defining them. So here's the proportion in the sprayed area of the trees killed by moths, and here's the one in the non-sprayed area. You could do P sub 1, P sub 2, but you have to do 2. All right, the biggest mistake I saw was in the hypotheses, all right? Leaving it out. And a lot of people just left it out. How can you possibly continue if there are no hypotheses or no claims to check for evidence for? So, yeah, you definitely have to include it. What I also saw were people doing HA like this. All right, that's a big mistake. It says lower. Right here. So it's a directional test, and this, not equal to thing is going to throw you off. It's going to double the p-value. Now you do end up with the same conclusion because p is going to be greater than alpha either way, but you could risk in another problem, switching the conclusion from, rejecting HO to failing to reject HO because of that mistake. So don't make that mistake. It tells you in the problem it's directional. The only other way it couldn't be is if it said, does it indicate that the proportion of spruce trees killed by moths is different in the sprayed areas? All right, assumptions. I think this is going to be similar to what they were on page 1. So make sure that you're listing and verifying all of them. Again, this you're going to have p hats for both. You know that. All right, name your test. And so your p-value should have been this. This is what I was pretty much looking for. And again, if that's twice this, then you either did a not equal to, or you just picked the wrong alternative in your calculator. Now the issue here is this little bitty alpha. All right, we're really used to having alpha of 0.05, and this is, a fair sight smaller. This, if I hadn't had the alpha, I would have rejected HO. But now the thing is, since I do have this alpha, this is telling me, since I committed to using it, that is my cut point. Anything bigger, I'm going to fail to reject. So here, this is bigger, I'm going to fail to reject. Anything on the other side, you are going to reject, right? Because this is the level that you've chosen for, for how extreme you want your evidence to be. One thing that I noted was that a lot of you got, tried to be intuitive and said, well, the p-value and the alpha value are almost the same thing. So this means that this may not be practically significant. Well, you know what? That's really, it wasn't significant in the first place. So the argument as to whether it was practically or not is sort of moot. Had you rejected, like if you were just a tad bit beyond 0.01, I don't think I would still make that argument about practically significant. Your sample sizes are not tremendously big. I mean, they're big enough, but they're not in the tens of thousands. And if you're going to be beyond 0.01, that's pretty, solid evidence, even with big sample sizes. Now, maybe not big sample sizes, but, that anything below 0.01 is pretty substantial evidence against HO. But again, you were not even less than alpha, so that argument doesn't really hold water. So P is greater than alpha, the results are not significant, we fail to reject HO. I need those three things. Like I would get, since P is greater than alpha, we're going to reject HO. You have to say the results are not significant. If you left that out, it was -2. So please don't leave that out. Just follow the script. I'll give it to you. Why not follow it? And then, end your discussion here with something that relates your decision back to the original. Okay, so I think I've said pretty much all I need to say about this problem. So let me go ahead and we'll move on to the third. All right, so here is the third page, and perhaps in general this was, where kind of the worst of the worst happened. I know that this is a relatively new subject, but we did cover it and we did have an extra day to cement the topic, so I didn't feel bad about throwing it out there. But the last three questions were worth 10 points each, so that's a quick journey from an A down to like a C or a D, whatever we count a 70 as. But let's look at it and try to clean it up. This is very reminiscent of my example that I gave you off the cuff with the Homer Simpson example, only this is discharge water that can't be any hotter than 150, because any hotter than that, it has environmental consequences when it leaves the plant into whatever you're dumping it into. So here's HO, here's HA up top, and the type 1 error is to reject HO when in fact it's true. So the temperature is in compliance. So it is true that it's 150, in a type 1 error situation. But we think it's hotter, so we could shut down the plant. We could check into it and take time away from doing whatever the plant's supposed to do. But in other words, we're just going to implement procedures to lower the temperature when it's not needed. That's not great, but it's not the end of the world. I was surprised at letter B, the number of people who missed this, all right? The probability of making a type 1 error is whatever alpha they give you, right? Now don't just say, oh, it's alpha, and then just walk away, because we're asking in the context of this particular situation. Well, alpha is 0.05, so I needed you to say 0.05. If you just said alpha, that was minus a point, because you could get more specific than that, all right? So yeah, please do. So most people did fine. Oh, in the type 1 error, people that missed it did not put down the consequence. I mean, you're supposed to do two things, describe the error and its consequence. So if you left off the consequence, that's -2. That's like half of the problem. Same thing for letter B. I needed you to describe the type 2 error in context of this. So you just don't want to say it's where we fail to reject HO when it's false. Okay, that's great. But this is where we're doing it in the context of this situation. We think the discharge water is in compliance with regulations, but it isn't. So it gets released and the ecosystem may be harmed. and the power plant may be fined. These are things that seem to be pretty reasonable. So 2 points for a description of the error, 2 points for the consequence. All right, this next one, which I think is number 4, yes. This is about the drug thing, and a lot of people missed this. And the reason that you missed it is because you didn't take the time to write out HO and HA. Well, HO is just a statement that there's no effect, there's no difference, there's nothing out of the ordinary, there's nothing that should be different from what I'm told, and so here, since you're comparing 2 drugs, the 2 drugs are the same, right? And HA is that the new drug is different, because they kept saying that the new is better, and they said it somewhere else in here. I'm not going to take up your time while I try to find it, but they really emphasize that. All right. So if their test is telling us that there is no significant difference, but the new drug is really better, there it is, then you are failing to reject HO when it's not true. You're accepting it when it's false. That is a type 2 error. That's why A is correct. Okay? All right. Now, I still had people messing up on 5 and 6. And, you look at these scenarios and let's see. The HOs are the same. The HAs are the same. N is the same. Sigma is the same. But alpha is different. Okay? All right. Basically, when you raise alpha, so if alpha goes up, then power goes up. And you can put, that beta goes down and power goes up in between, but if you can remember those 2 things, that'll help, right? So the bigger alpha gives you the most power, all right? Same thing here. Let's see. Alpha's the same, HO, HA, sigma's the same, but the sample size is different, right? And this is the one that's bigger. Well, whichever one is bigger, that's going to raise your power. So as N goes up, then power goes up. Okay, that's what we learned. So that's your quiz. I'm going to pause and then I'll come back with a few test topics. All right, so I just glanced at the test, and so here are some things that I think would benefit you to pay some attention to. All right, so make sure that you can read a scenario and translate it into a correct HO and HA, and then be able to know based on what the test results are whether to reject or not. So that's pretty standard stuff, but it can be done wrong. Power and that sort of thing. Understand type 1 error, type 2 error, and power, what they mean. Type 1 error is to reject HO when it's true. Power is that we will reject the probability of rejecting a false null hypothesis, all that kind of thing. Probabilities, that would be more of a relationship. For example, that type 2 error and power, those 2 probabilities are complements. So as one goes up, the other directly goes down, and they both add up to 1, that sort of thing. And then which scenario has the biggest power? Kind of like the last 2 questions on the second quiz. So think about that. I would be able to correctly calculate desired sample size and do it relatively quickly. I don't think that's something you should sit there and think, oh, I did that at one point. Yeah, I remember. Well, wait a minute. Don't linger on it. Just throw out, the formula, fill it in, get the answer, and move on. Remember, the biggest thing is figuring out what P star is. It's going to be the value from some prior study or a pilot study or something like that. Unless they don't tell you about, a value like that, then you pick 0.5 as your conservative. Be able to interpret a confidence interval. For that matter, I think I'll even say be able to, interpret what a p-value is. So a confidence level, I really can't go into that anymore. I know that there's a way that we write it up when we write up an estimation problem using a confidence interval, but just look into it. Remember, you're trying to trap the true proportion. That's probably the best thing to keep in your mind if you're choosing between options. The power of a test, that's the probability of getting the sample results you got or more extreme than that, given that HO is true. All right, so know those things. Understand the effect of changing sample size on the width of the interval. Okay, you're changing the margin of error. Didn't we have a rule for cutting the margin of error in half? There was something that allowed us to do that, so look into that. That'll help. Look at the formulas for a 1 prob z interval and for a test statistic for a 1 prob z test. I think you can use a formula chart if you want, but definitely I don't think I would pester you with 2 proportions, since those formulas are a little bit out there. All right, when you're doing multiple choice questions, whether it's for this test or the AP exam or for any test, definitely read through all of them. Don't be swayed by the first one that you think is right. Just confirm that anything that comes after it is not more right. Sometimes you get a question where they'll give you 3 or 4 different answer choices, and maybe 2 of them will be correct, or 1 of them will be correct, or all 3 of them will be correct. So read through the answer choices and make sure that you can put a C for correct, or an F for false, or a T for true, or an F for false, so that at the end, if you have like Roman numeral 1 or Roman numeral 2 or Roman numeral 3 or any 2 of those or any 3 of them. All right, so in other words, when you do multiple choice questions, do it thoroughly. All right, ways to increase the power of a test of significance. Increase alpha, increase sample size, wider alternatives farther apart from the null will increase power. So those are the 3 things: increase alpha, increase sample size, or pick an alternative that for a hypothesis that's farther away from HO. After the multiple choice, you'll have 2 questions of conducting formal inference in an FRQ format. They could be 1 prop z procedures or 2 prop z procedures, or 1 of one and 1 of the other. So make sure that you go over those quizzes and that you have your formal write-ups the way they ought to be. So on that note, I think I've given you everything that I can give you. I will close out. Stay warm. I don't know when we're actually going to have this test, but hopefully this week. So take care.